graph the following piecewise function. And here we are given f of x is equal to negative 2x plus 3 when x is strictly less than 2. And then we have f of x is equal to x minus 4 if x is greater than or equal to 2. So observe here, we have a piecewise function with two distinct equations. So in order to sketch a graph of a piecewise function with two distinct equations, we need to set up two distinct tables of x and y values. So our input values here determine which equation we are going to use for our output. So in case 1, when we are considering input values that are less than 2, we need to be using the equation y is equal to negative 2x plus 3. So be careful here. When we have cases like this where x is strictly less than a constant, even though x cannot equal that endpoint, we still need to consider it on our table of values because our graph can get infinitely close to it. So we'll make a little love note here that will have an open hole when x is 2. So plugging these x values into the corresponding function, we have the following. So looking at our endpoints, we have when x is 2, y is negative 1. So this is the first solution point. And now again, keep in mind that this is not actually on the graph. There is a hole or an open circle at this point on our graph. We're also observing that when x is 1, y is 1. And last but not least, when x is 0, we found that y is 3. So plotting these ordered triplets on our provided coordinate plane, we have the ordered pair positive 2, negative 1. And again, keep in mind there's an open hole at that point. We then have the ordered pair positive 1, 1. We should label our first point as well. And then last but not least, we have the ordered pair 0, 3. So as always, connecting these points with a smooth curve, we can see the graph of our first equation. Y is equal to negative 2x plus 3. Now, we also need to consider case number 2 here. When x is greater than or equal to 2, our function is defined by the equation y is equal to x minus 4. So when we plugged our inputs into the corresponding equation, we found that when x is 2, y is going to be negative 2. We found that when x is 3, y is negative 1. And last but not least, when we substituted 4 into this equation, we found y to be 0. So plotting these points on our provided coordinate plane, our first ordered pair at 2, negative 2. Our second point here is at positive 3, negative 1. And let's move this over a little bit. So again, at the ordered pair, positive 3, negative 1. And last but not least, we have the ordered pair 4, 0. And to see the graph of this function, we'll connect those points with a smooth curve. So one final observation here. Notice on the provided coordinate plane that there is a gap between our two graphs. We have the open hole from equation 1 and then the point below it. So a jump or a gap like this is telling us that our function is not continuous on its domain.